Hi everybody, I'm Vincent Racaniello for the American Society for Microbiology. I'm at Boston University at the Emerging Infectious Diseases from A to Z conference, and I've taken a few of the speakers from today's session and going to chat with them a little bit about what they've been talking about. My guest now is from the University of California at Berkeley, Eva Harris. Thanks for talking with me.
Thank you.
I know I am the only one between you and lunch, so I'll make it quick. Tell us, you've been working for years in Nicaragua, and you've been on TWIV before, and you've talked about dengue in Nicaragua. Tell us a little bit about Zika. What's the extent of the Zika transmission in Nicaragua?
Well, right now it's huge. Essentially the epidemic took off, I would say, at the end of June, and I mean, honestly, I've never seen anything like it. It was just amazing. I've been there a couple times during the epidemic, just came back, and I mean, you really feel like every single person is infected. And with Zika, I mean, there was this talk of it being largely asymptomatic. I think it's because people weren't looking for the right symptoms. Because really, I mean, it's just astonishing. I mean, our personnel, our labs, the people in our studies, their families, it's a really kind of amazing feeling to have it going that intensively.
Yeah. Did you get it?
No, actually. Well, so far, but I will be doing my antibody test soon.
Yeah, you'll see.
Yeah, not yet.
So
I'm going soon again. So
what fraction of the population is infected? Do you have any sense?
See, we don't know that yet. What we've been doing is for dengue and then for chikungunya right after that, we've been doing a number of studies. Our cohort study that follows children, but we also, where we can tell every year, we have healthy blood samples, which allows us to do not just seroprevalence, but rather seroincidence, because we have a time dimension there. And so for we started chikungunya, which was the last epidemic. That was last year. So we instituted seroprevalence studies, not only in our pediatric cohort, which we cover kids 2 to 14, but we also did an age-stratified seroprevalence study all the way up to 65 years by 10-year brackets. And then we repeated that the next year on the same people so that we could see the first and then the second wave. And now we're going to do that the next year for Zika. The problem, so right now we don't know what the incidence is because, and we don't actually have the tools right now to do really the study that I'm even discussing because of the cross-reactivity of antibodies between Zika and dengue. Although I think that by the time we do that study, we're very, very close to having an assay that works. And I think that for research studies, we'll be able to distinguish.
Okay. So the first cases of Zika were when in Nicaragua?
So really, officially in January is where we had our first cases of 2016. So January, February, and then the way the seasons work in Nicaragua, in March and April is the driest months. And so we generally do not see mosquito-transmitted diseases during that time. And in fact, we had a lull. And then by around really June, end of June, it was really taking off. And then, like I said, we had just enormous amount in July and August.
So do you soon expect to see cases of microcephaly associated?
So we're actually, I'm the principal investigator of a study in collaboration, of course, with the Ministry of Health in Nicaragua, which is sponsored by the National Institutes of Health, the NIH. And it's a multi-center and multi-country study called ZIP, which is Zika in Infants in Pregnancy. And that is, so there's 4 sites in Brazil, 2 in Puerto Rico, Colombia, Guatemala, and Nicaragua. And so we're going to start, we've been feverishly getting ready for this study, and we're going to start enrolling very soon in November. And so there was one case of microcephaly that was already announced by the Nicaraguan Ministry of Health. But again, fewer people were infected in the early months. And so now we'll potentially be seeing cases 6 months from now.
Okay.
Yeah.
Would be nice if there weren't any, wouldn't it?
I was thinking, maybe it won't happen in the rest of Latin America the way it's happening in Brazil, and I think that it might be somewhat less. But I mean, I think the issue right now, and the reason we need this study, and many countries actually and consortia are doing these pregnancy studies. I think it's really critical because all of the Brazil studies had no denominator. So all we were seeing were the cases. We have no idea what the risk is,
Right,
you know,
right.
and so we don't know, and we certainly don't know in asymptomatic women as well. So this study is specifically looking at symptomatic and then asymptomatic.
Right, yeah.
And so that's going to be, I think, something interesting.
Yeah. Now you mentioned in your...
And tragic too. I mean, I have to
Of
say,
course,
it's
of course.
very distressing because we talk, oh, this is what we need to do next in this study, and you know, we'll be diagnosing women, and then there's kind of nothing right now that we can offer.
Yeah.
It's
hard.
intense
It's science, but then
ethic.
there's a human side.
There's a huge
right.
ethical issue. Yeah.
So we're familiar with Zika being transmitted by mosquitoes, but
Yeah.
in your talk today, you
Yeah.
mentioned there might be other ways.
Yeah, so I think for the most part, I mean, definitely mosquito transmission is driving it. And I think one important thing is that it may not only be the kind of standard way we think of mosquito transmission, which is that the mosquito ingests the virus and then it goes through the midgut and then it replicates and goes to the salivary glands, and that takes maybe 8 days or so, and that's called the intrinsic incubation time. But I think what also is going on is that there could be mechanical transmission. So essentially, you could have the mosquito biting somebody, picking up the virus, and going to the next person. So it could be going even faster for that reason. There's also sexual transmission, and I think definitely that is happening, but you're going to see that mostly in the United States or places where right now we don't have epidemic transmission via mosquito.
Right.
So if it's going on, it's probably going on, but we have no way of knowing under that basis. But the feeling was, it was just that we started a household transmission study just to look at potential other routes of transmission because it felt so intense. And we have, for instance, I think I mentioned, we're also working in communities to, essentially with community-derived methods for controlling the mosquito.
Right.
For both, well, actually all three, dengue, chick, and Zika. And so we have one, what we call them barrios, one neighborhood, where they're really, really good at this, and there were just no mosquitoes. And yet, we had an index case come from the Zona Franca, where there's the kind of the maquilladoras, and then that family got infected, and then the whole block, it just went right down the block. And even our coordinator, our study coordinator, and his child were both infected with Zika, and yet, really, there were no mosquitoes. And so we were thinking, maybe saliva could be, maybe it's some person to person. I can't say anything yet. We're collecting data, and even our data is not going to be definitive because everything's going on. But I think that we need to, for instance, with chikungunya, we isolated live virus out of saliva, and we're in the process of doing that now with Zika. So I think it's possible.
Well, you said you're going to do a household transmission study, but now everything's stopped, so you can't do it at the moment, right?
No, we're continuing.
You're doing it now?
Yeah, it's just the transmission went down a little bit, and then, you know, it's going to,
okay.
Who knows how long it's going to go on.
So let's talk a little bit about the antibody cross-reactivity issue. We know for dengue, antibodies can make disease worse. What do we know about Zika?
We know very little, and I think there's kind of two elements of that. There's the what can happen, and then there's the what does happen. And so I think, so right now, a lot of people are testing acute and convalescent sera, which means right at the moment of the disease, and there's always a lot of cross-reactivity among flaviviruses, and so that's the group of viruses to which dengue and Zika and West Nile, for instance, belong. And so we often expect to see cross-reactivity at that time, especially for what's called IgG antibodies and even neutralization tests at that point can be cross-reactive. And so the key is really looking over time because, and actually a colleague of mine, Aravinda Da Silva, has shown that in travelers, for instance, when you have remote samples, there's really very little or no cross-reactivity between dengue, for instance, and a Zika virus, dengue antibodies and a Zika virus. It might be different to some extent in endemic areas because we found that there's I think there's natural boosting, and so there's kind of, it doesn't look as clean in endemic areas as it does in travelers. So, but I think the critical point there is going to be to do studies over longitudinally. And for instance, we have studies where we collect samples over 3, 6, 12, 18 months, and also up to 7, 10 years. And so we're in the process of using those samples to look how does that change over time. Another thing that we did was use our mouse model, which specifically looks at the enhanceability, essentially, and it's called antibody-dependent enhancement. And one of the experiments was a collaboration with Davide Corti and Federico Sallusto and Antonio Lanzavecchia, who had just made, they were based in Switzerland, and they had made a series of human anti-Zika monoclonal antibodies. And so we tested a couple of their antibodies in our mouse model and found that a human anti-Zika antibody that was cross-reactive to dengue and recognized both Zika and dengue actually lethally enhanced an otherwise sublethal infection of dengue in our mouse model with a vascular leak syndrome. Now, that was not surprising because that antibody in vitro looked exactly like a cross-reactive dengue antibody.
Right.
So its in vitro curves for neutralization and enhancement looked identical to another antibody that we had analyzed with the same group previously. So it wasn't surprising, but it does say that humans are making antibodies that in isolation can be enhancing.
Right.
Now the question is, after a vaccine, after a natural infection, it's all the balance. If you've got much more neutralizing antibodies, even over time, those can win out. If you have a suboptimal vaccine, as we've seen with dengue, for instance, or Zika, that could be a problem. But we don't know that. We just know that it's possible.
And we also know that antibodies to dengue can enhance Zika infection in vitro.
Exactly.
Right? Several groups have shown that.
Exactly. And so that hasn't been shown yet or published yet in terms of animal models. There are some work showing that we don't see it, and I think again it's going to be a question of numbers and of time and
But you're going to be looking for that as it goes
and
on.
so far I have to say we haven't seen that much. Well, we just don't know yet. We haven't seen any severity hints, but it's very, very early.
Right. I mean, this could be a concern for the dengue vaccine, which is currently being distributed. Are they going to be using that in Nicaragua? Do you know?
No, not the existing vaccine right now. They're doing another trial on a different vaccine, but in Nicaragua actually. But right now, there's no plans to roll that out. The one thing I have to say that it's interesting. We have another set of studies looking at the ability of antibodies to facilitate transfer across the placental barrier. And there's two aspects to this. One is the ability of the antibodies to help transcytose, which is to get across, and the other is once across in the villus core, the ability to potentially enhance fetal macrophages or Hoffauer cells in the villus core. So there's kind of two aspects, and it's interesting because there's two different types of receptors. So there's the neonatal FC receptor, which would be involved in the transcytosis, and then there's potentially the FC gamma receptor too, which would be involved in the. And so we actually have mutations knocking out each type of interaction, and so we'll see what happens with that.
So the possibility is that having been infected with dengue could lead to a more severe Zika disease.
Or it could lead to less.
Or less.
Actually, I mean, if you had really strong antibodies, those should be able to get across. And transcytosis is a good thing. I mean, it gets antibodies to the baby, to the fetus. It's just that in the context of a flavia infection, if you have the wrong kind of antibodies, there's the potential for making it worse, but there's a potential for being protective.
And again, this is what we'll find out going forward as we do the epidemiology, right? Now, you mentioned earlier this problem with cross-reactive antibodies in terms of diagnosis. So where are we with that now?
Yeah, so there's standard diagnoses, the way we've done them, essentially don't work because there is just a lot of cross-reactivity between dengue and Zika. So kind of the whole Latin American dengue surveillance system collapsed because we can't use those. We can't use those standard methods right now. But there is a lot of activity by many different academic groups and industry trying to come up with specific tests. And I think we're already starting to see some results. So for instance, the same group, Davide Corti, they developed what's called a blockade of binding assay based on anti-NS1, which is NS1 is a secreted viral protein to Zika, and that worked beautifully in their hands. And we actually have that in Nicaragua now. It's a little more complicated in endemic sites because it's not as clean, meaning there's more flavy antibodies than you have in travelers. But I think that looks promising. There's another, Dr. Ian Lipkin, for instance, has just identified a peptide actually using some of the Nicaraguan serum, which looks like it's discriminatory, and many other groups are making progress.
Great.
I think that in the next couple months, not too many months, we will have tests that are at least for research use. And then the real challenge is going to get that
in the field,
and into national surveillance programs. But I'm hopeful that that will happen because it's a necessity.
Sure. Can you tell us about Zika Chat?
Oh yes. Well, I think now I'm remembering. I think on the TWIV, I think we discussed the community-based project that it was called Camino Verde, and it was essentially a way of bringing evidence to communities so that they could come up with their own ways to
Right.
intervene in the mosquito life cycle. And thereby we showed, using a cluster randomized controlled trial, that we could bring down mosquito infestation rates and also dengue infection rates and self-reported dengue. So the next phase of that has been to take that kind of those lessons learned into a new a cell phone based method, which I might have mentioned as dengue chat, which is now evolved through chick chat to Zika chat. And it's really being led now by Dr. Josefina Coloma in our group, and with James Halstead, also from Berkeley, and a group in Nicaragua, where what it is essentially is a way of motivating and documenting the destruction of breeding sites, because really the problem with all of these arboviruses, dengue, chick, and Zika, is that they're transmitted by a mosquito that breeds in clean water inside your home in the most unlikely places. I mean, like a Coke can cap,
Right,
or a puddle, or
Yep.
the barrel where you have clean water. And so the key thing is to identify those sites and eliminate them.
Right.
And so what this does is have you take a picture, or you document where the site was, and then that you've actually gotten rid of it. And as you do this on your cell phone or sending messages, you actually accumulate points, and so you become a Zika warrior. And so kids love it. And the cool thing is that it then transmits to a website, and you can actually mark the progress. So you can not only see a heat map of where there's activity, but you can actually see which houses are becoming greenhouses, how you're moving in terms of getting rid of these sites. And then the kids and everybody, really, the community can watch that in real time and see how they're doing. So it's like their direct access to evidence and seeing how they're progressing. But then it also serves as a blog and as different ways to communicate information. And so it's
brilliant.
A neat thing.
It's brilliant. I view it as an extension. I know you as someone who doesn't just want to march into a country and do work, but you want to teach them how to do it and imbue them with that. And this is an extension. You get the kids to report.
Absolutely.
the
Only they're
infectious
teaching
disease.
us.
That's right. That's right. That's
because
just great.
they're the ones with the ideas.
That's wonderful. I've been speaking with Eva Harris of the University of California at Berkeley. Thank you so much for talking with me today. I'm Vincent Racaniello from Columbia University for the American Society for Microbiology. Thanks for watching.